All right, so last week we were looking at a new equation called the quadratic equation. And we found out that this equation, it was an equation that involved an x squared in it, x to the power of 2. Or sometimes it was written as an x times an x instead. But we noticed that these graphs, they always looked like a U shape. And sometimes they opened up, sometimes they opened down if there was a negative out front, but a parabola always had an x squared or an x times x, and it always followed a U shape. We also found out that if you made a table of values to graph it, the second differences would always be the same. And this equation is useful, if you're trying to model something that follows this sort of pattern, right? Whether it's an object or something in physics or maybe finance. So today what we're looking at is we're looking at a different form of that equation called the factored form. So just kind of a quick reminder of what we saw last week, right? Y equals x squared is your quadratic U shape. Second differences are the same. And in this case, the coefficient is the number out front. There's nothing there, so it's like a +1. If it's positive, it means up. In today's lesson, we're looking at a little bit different way to write the equation. It's called the factored form. And in the factored form, you have two different x's that are multiplying together. So for example, like this guy here. It's still a quadratic because it's x times x. It's just written in a bit of a different way. There's actually three different forms. So far we've seen the standard form that we saw last week with the x squared. Today we'll look at the factored form. And the different forms, they just give you different information. So depending on what you're trying to do with this parabola, with this quadratic equation, you might choose one form over the other. So at this point, I'll get you guys to pause the video, see if you can go through and graph these three equations out using Desmos, and then see if you can look through and kind of compare the shape of the graph to the equation and see if you can notice any patterns. So I'll let you do that right now. All right, hopefully you had a chance to graph those out. Let's go through and see what you got. So first one, plug that into Desmos, and I got a graph that looks like this. X times x, sure enough, it is a parabola, it's a U shape, and it looks like it was hitting the x-axis at 2 and 4. The next one, all right, I graphed this guy out, and once again, it was parabola, positive, it was opening upwards, and I noticed that some of the key points is that it was hitting the x-axis at -3 and +2. And my last one, before I even graphed it, I noticed, oh, negative out front, this guy's going to open downwards. It's going to be upside down U. And there we go. And I noticed some of the key points I noticed here was this one was hitting the x-axis at -2 and +1. All right, so now that we've got some of the points listed in there, I want you to go back again and look at the equation, look at the x-intercepts that we plotted, and do you notice any pattern there? How do the numbers in the equation match up with the graph? All right, so hopefully what we noticed is that in factored form, the numbers that show up in the brackets in the equation are actually the opposite sign as to what your x-intercepts are. So in this case, -2 in the brackets gives me +2 as an x-intercept. -4 in the brackets gives me +4 as an x-intercept. Over at the next one, +3 in the brackets gives me -3 as an x-intercept. -2 in the brackets gives me +2 as an x-intercept. And even on the last one, +2 in the brackets was a -2 x-intercept. -1 in the bracket was a +1 x-intercept. So the factored form actually gives you the x-intercepts right away. All you have to do is take the numbers out of the brackets and swap the signs. That's what we found out here. Right? You switch the signs in the equation to get the x-intercepts. Let's think about why that is. Well, an x-intercept always happens when you're on the x-axis. It happens when your y value is 0. So in this case, how would you make the y value 0 in this equation? Well, you would just plug in the opposite number, right? In this case, if I plugged in a +2, 2 minus 2 is 0, my equation's 0 now. right? Oh, that matches up. That would be on your x-intercept, right? On your x-axis. And over here, if I plugged in the opposite of this, if I plugged in a -3 plus 3 is 0, everything's multiplying by 0, that would be on your x-axis. So it makes sense that the opposite sign, the opposite value, is the x-intercept. All right, so some conclusions that we have now. From last week, a parabola opens up if there is a positive, or if there's nothing, it's like a +1 at the beginning of the equation. Right, happy. A parabola opens down, sad, if there's a negative out front. To find the x-intercepts, you look at the factored form, if you have the factored form, and the values are inside the brackets. You just swap the signs. All right, next activity. Over here, you're given a, I think there's 5 different parabolas here. Sorry, these ones are a little bit grayed out, but there's a D down here and an E down here. And what you need to do is try and match up the equation with the graph. Some of them are in factored form, right? These 3, and then 2 of them are in standard form. So I'd say at this point, maybe pause the video, see if you can try matching them up, and then come back and check your answers. So I'll let you try that now. All right, hopefully you had a chance to match some of those up. Let's look at our first one. So first one, I notice there is a negative out front, so it needs to open down. I notice it's factored form, so it should have x-intercepts of, switching my signs, +6 and +8. So in this case, x-intercepts +6, +8, opening down, that guy's got to be E. All right, let's jump down to the next factored form. Next guy, positive out front means it's opening up. It's factored form, so I'm going to swap the signs to get my x-intercept. So I'm looking for an upwards parabola that has x-intercepts at -4 and -9. -4, -9, opening up. Oh, that's got to be A. All right, let's go to our last factored form, right? Factored form is nice if we have our x-intercepts. Once again, positive out front, nothing there. It's like a +1 out front, opening up. And x-intercepts at -1 and +3. -1, +3, opening up. That's got to be B. All right, now we'll go back and look at our last 2. These ones are in standard form, right? X squared is when we're in standard form. So we don't know anything about the x-intercepts. And in fact, looking at the 2 remaining graphs, there actually aren't any x-intercepts on those. Let's see here. Well, since we only have those 2 to match, we could actually just do it from the direction, right? This guy is a positive out front, so it has to open up. It has to be C. And this guy down here is negative out front. It has to open down. That would have to be D. Those are my only remaining ones. What we also know that is, or notice, is that in standard form, this last number, the last number that's on its own, that always matches up with the the y-intercept. So in this case, +6 at the end, y-intercept of 6. -4 at the end, y-intercept of -4. So the standard form is useful for giving you the y-intercept. All right, let's do some calculations with these. Oh, I think I've given you the answer, but ignore that for now. Okay, so we are asked, given this equation, graph the following equation without making a table of values. Okay, so first of all, I notice, okay, x times x, it's a parabola. I know it's going to be a u. I also notice it's factored. First thing, positive out front, nothing there, +1 out front, opens upwards. Okay. Factored form, I should be able to get my x-intercepts pretty easy from this. Swapping my signs, my x-intercepts are +2 and +4. And you could actually go and graph these over here, +2, +4. Okay, now we almost have enough information to graph it. The only thing is we don't know quite how far down it goes, right? Because we only have the 2 points. So I don't really know, right? Does it only go down a little bit like this and then back up, or does it go way down like this before coming back up, right? So I do need a third point in order to figure out how far down it goes. Okay, so what else can we figure out here? Well, we can actually get our axis of symmetry. So hold on, what was the axis of symmetry again? Axis of symmetry was that line that runs right through the middle of the parabola, right through the middle of the U, and it splits it in half. It's the same on both sides. It's symmetric. And in this case, the axis of symmetry, it always goes through the vertex, through that bottom point, and it's halfway in between the x-intercepts. So, okay, hold on. Halfway in between, okay, if I know it's 2 and 4, the axis of symmetry has to happen at x equals 3. Okay. You can calculate it. If it doesn't work out nicely, if it's a decimal number, you can calculate it by just adding your x-intercepts and dividing by 2. Sure enough, that comes out to x equals 3. Okay, so I know that my vertex has to be somewhere along this line, but I still don't know where to draw it, right? Is it here? Is it way down at the bottom? So what we can do is we can take that x value and substitute it back into the equation. So we're going to plug x equals 3 into our equation and figure out what the y value is at that point. I take my equation, replace the x's with 3, and I solve this. 3 minus 2 is 1, 3 minus negative 4, negative 1. So y equals negative 1. Okay, that gives me a point, 3 and negative 1. Okay, now I can plot in 3 and negative 1. Now I've plotted that last point, and now I know how far down it goes. I can graph my parabola. You need those 3 points to graph a parabola. All right, there we go. So main thing, your coefficient gives you your direction. If it's factored form, you immediately know your x-intercepts. And in order to get that third point, the vertex, you just take your axis of symmetry, halfway in between your x-intercepts, plug it into the equation to get the y value to get the point. Let's try one more here. All right, so at this point, maybe I'll let you pause it and see if you can try this one out, and then come back and check your answer. So I'll let you try that out now. All right, hopefully you had a chance to try this one. Let's see what you got. So first thing, it is a parabola. It's positive out front, meaning it opens up. Factored form, so I know my x-intercepts right off the bat. Swapping the sign, negative 1 and positive 3. Halfway in between that is my axis of symmetry. I can sketch it in like that. And I know that that is at x equals 1. If I wanted to calculate it, I would add my x-intercepts and divide by 2. X equals 1. Only thing is I don't know where the vertex is. So I'm going to take my x equals 1, plug it into the equation, substitute in x is 1. And we calculate that out to, see here, 2 times negative 2 is negative 4. So there's my vertex, 1 and negative 4. Now I can sketch it.